Hello everyone, welcome back to Olsen Cafe. Now today we will learn a new rule in differentiation called the product rule. You will learn in this video that by expanding, it is not the most efficient way to differentiate this expression. In this lesson, there are two basic questions that you must know when applying product rule. Now for these questions, they are also known as composite function, whereby there are product of two terms over here. So if you look at the product rule, it goes by u dv dx plus v du dx. Now what does this mean? Right, it simply means that I am going to fix the first and then I differentiate the second. So which means if I have two terms, I have first term which is u, and then I differentiate the second term which is v prime. Then with this, I'm going to plus a term which is I'm going to fix the second which is v, and then I'm going to differentiate the first term. So this is a very useful formula for product rule. So let me show you how to do and how to apply product rule over here. Before we dive into product rule, let us recall this example which I went through on my first video on power rule. Now in this example, there is also a product of two terms, but in this case, we can find the derivative very easily by expanding because, all right, for each of the term, there is no additional power over here. So by expanding, what I'm going to do is, I will have x to the power 5 minus x cubed. Then I'm going to do the rainbow method for the other terms. I will have plus 2x squared minus 2. So once I derive here, I will be able to apply power rule. I'm going to differentiate them individually. I will be able to get the derivative very easily. However, in this example, you notice that there is a power for the second term over here, the second function, right? So it is not practical to expand the terms before you differentiate. It will not be efficient. So we are going to apply product rule over here. So let's go through step by step. So I have fixed the first and then differentiate the second. So which means I'm going to have the first function, which is u, and differentiate the second function. That means I need to find what is the derivative of v. So to do this, I'm going to label this as u and v respectively. So since I need v prime, so therefore v is equals to 2x plus 3 to the power of 3. So I'm going to apply chain rule over here. So to find the derivative, so what is chain rule? Which means I'm going to differentiate the outside, then the inside. So the outside here, it means I'm going to bring down the power and then power reduced by 1. So I'm done with differentiate the outside. So now I'm going to differentiate the inside, which gives me 2. So the first half of the function is done. All right, now I'm going to move on to the second half. So the second half, I'm going to fix the second and then differentiate the first. So to do this, what is my first function? My first function here is u prime. All right, so which means I'm going to have u equals to 2x minus 1. So to find u prime, I'm going to have, which is 2, right? Very easily by using power rule. Now what I'm going to do is I'm going to combine these two together, right, and substitute into the formula. So what I will have here, right, the derivative, I will get u and then v prime, so which means 3 times 2 will give me 6, and then I just simply sub in, and then the second half, right, will be v, and then multiply by u prime. In this case, u prime is 2. Now, so once I have this here, I cannot just leave the expression like this. I will need to further simplify this. All right, so how do I simplify? You observe that, right, there is actually a common term, which is 2x plus 3 squared. So what I'm going to do is I am going to factorize out this common term, which is 2x plus 3 to the power of 2. Now, once I factorize this, so if you look at the first half of the expression, all right, so what is leaves us with will be 6 bracket 2x minus 1. All right, and then I look at the second half, so I will have 2 times 2x plus 3. Since I have already taken out the 2. Alright, so what I have here is I'm left with 2x plus 3. Now what I'm going to do is I'm going to expand, alright, the expression right inside the square bracket. So what I'm going to have here is this will give us 12x minus 6 and then plus 4x plus 6. Now, so what I'm going to do is simplify this expression, right? This will give us 12x plus 4x. This will give us 16x. And then I multiply by 2x plus 3 squared. So the derivative of this expression y is done. In this last example, I would like all of you to pay attention and fully understand. Now, this is a very common question that you get in the examination. Let's apply product rule step by step. So let's begin with fix the first and differentiate the second. So I'm going to fix the first, which is u, and then find v prime. So with this, all right, again, I'm going to define u and v respectively. So since I need to find v prime, so my v is equals to 3x plus 5 to the power of half. So again, to find the derivative, I'm going to apply chain rule. So to do this, I'm going to have, all right, bring down the power, differentiate the outside, then the index I subtract by 1, which is negative half. So once I'm done with this, I need to differentiate the insides. So this will give me 3. Now, so if you understand and remember what I mentioned in my previous video on chain rule, right over here, I have a negative index. So whenever I have a negative index, what I'm going to do is I'm going to make it a point to rewrite this right into a positive index. This will help us a lot later on. So by writing it down as a positive index, I will have 3 over 2 square root of 3 plus 5. So do take note of this. Now, so the first half of the expression is done. So I'm going to look into the second half, which is fix the second and then differentiate the first. So which means I'm going to have v and then times u prime. So what is u over here? All right, u in this case is equals to 2x plus 1. So to find the derivative, therefore this will give us 2. So this is done. So I'm going to combine these together into the formula. So what I'm going to have is the derivative here equals to u and then times v prime. And then the second half, which is plus v and multiply by u prime. Now, so I am done over here. Now, at this point, I would like all of you to take note. You notice that the first part of the expression here, right, involves a fraction. All right, and the term here is square root of 3x plus 5, which is the same as the second term. So what I am going to do, all right, is I'm going to combine this into a single fraction. All right, so to do this as a single fraction, what is the common denominator? It is simply 2 times square root of 3x plus 5. All right, so therefore, for the first term over here, I simply just get 6x plus 3. And for the second one, do take note, if I'm going to combine this with the denominator, so this will give me 2 times 2, therefore will give me a 4. Now, how about square root of 3x plus 5 multiplied by square root of 3x plus 5? Yeah, this will give us 4 times 3x plus 5. So do take note of this term here. So the remaining steps is just very mathematical. So I just want to simplify. So therefore, expanding the second expression here, I combine them together. So this will give me 18x plus 23. And what is the denominator? Is 2 times square root of 3x plus 5. And this is how I find the derivative. So again, I will want all of you to pay attention to these types of question, especially how you combine the two terms into a single fraction. Right? This is a very important step that all of you will need to pay attention to. Hope you find this video useful. Do like and subscribe if this has helped you, and share it with your friend. I will see you in my next video, which is on Quotient Rule. Bye!